Welcome back to P1. Today we're looking at stretching graphs, Unit 4.5. Now we can stretch graphs in both a horizontal and a vertical direction. And much like translations, what happens outside of f of x affects the vertical direction, and what happens inside the brackets of f of x affects the horizontal direction. So y equals a f of x. A is outside of f of x, it's a multiplied by f of x. So this is a stretch in the vertical direction, scale factor a. When a is inside the f of x bracket, so f of ax, then we have a horizontal stretch. Now, just like with translations, what happens inside that bracket affects the horizontal, but you do the opposite. What this means is that we have a stretch in the horizontal direction by scale factor 1 over a. So what do these mean in the practical sense of it? Well, for the first one, y equals a f of x, what we need to do is multiply our y values by that scale factor a. For y equals f of ax, what we need to do is multiply our x values by that scale factor 1 over a, or divide those x values by the scale factor a. So if I'm talking about numbers, if I look at y equals a f of x, if I replace a by a number, let's say 3, then it becomes y equals 3 f of x, and what that means is that all my y values I would multiply by 3. If I look at y equals f of ax, if I replace the a in this one by 3, what that means is that all of my x values I would divide by 3. Before we get started, if you haven't subscribed to the channel, subscribe now. Let's jump into some examples. So first, let's remind ourselves what the graph f of x equals x squared minus 16 looks like. And here we have it. Now let's look at the first one, y equals 3 f of x. What that means is it's outside of f of x, so it is affecting my y values, but in the vertical direction, and it's a scale factor 3. So I need to multiply all my y values by 3, but my x values remain untouched. So what I end up with for a is a graph that still goes through minus 4 and positive 4. However, on the y-axis, it will now hit negative 48 because all my y values have been multiplied by 3. So a sketch of my graph would look something like this. Now for part B, I can see that it's inside the bracket, so I need to divide all of my x values by 3. So now I'm going to hit the value 4/3 and negative 4/3. However, my y values are unchanged. So my horizontal stretch looks something like this. And that's my y equals f of 3x. So let's look at this example. Sketch f of x equals x minus 1, x plus 3. So I know that x is going to cross at 0, positive 1 and negative 3. So my graph is going to look something like this. Cross in at 3, 0 and 1, negative 3. Now let's have a look what happens for parts B and C. So part B, you can see there is a minus sign outside. So what that means is it's effectively a scale factor of -1. And what's outside affects the y values or the vertical values. So what that means is that all of my positive y's would become negative y's because I'm multiplying them by -1, and all of my negative y's would become positive y's. So essentially this part of the graph would reflect underneath, this part of the graph would reflect above, this would be underneath, and this would be above. So I would end up with this. As you can see, what was below the x-axis is now above, what was below above is now below, below is now above is now below. So what I've ended up with is a reflection in the line y equals 0 or the x-axis. Now let's remind us what the original f of x graph looked like. Okay, and let's look at what happens for part C, where now my minus sign is inside the brackets. So remember, inside the brackets affects the horizontal direction, the x values, and I'm going to divide by -1. So what that means is that all my negative x values become positive, and these positive x values become negative. So I end up with a graph that looks like this. And what you can see is that it's now reflected in the line x equals 0 or the y-axis. Now it's time for you to try a few yourself. So here we have in black the original f of x graph, and then part A we're looking at 2f of x, so that means I'm multiplying my y values by 2, but my x values are going to stay the same. So my graph is going to have a vertical stretch. Now if you look at this value here, it is roughly 6, which means that my new value here is roughly 12. Now let's have a look at what happens at part B. So we're looking at y equals f of minus x. Inside affects the x. We're dividing them all by -1. So now we mean to reflect our graph in the y-axis. So we end up with something like this for part B. Part C is also affecting the x's, and we've got a half x. So this is the same as dividing all my x values by a half, which is the same as multiplying all my x values by 2. So I'm going to be between 0 and now I'm going to be between 0 and 10. So the graph is going to look very much the same. It's just a bit wider, same height, same y values, but it's between 0 and 10. And finally part D. This time we're multiplying outside by -2. So this affects my y values. So it's a stretch by 2, so twice the size of y values, but the negative also means it's a reflection in the x-axis, because what I'm doing is I'm multiplying my y values by -2. So the x values are going to stay the same. So we're still going to go through 0, and we're still going to go through +5. But my y values have been multiplied by -2. So this value, this point down the bottom here, is still going to be at 2.5, but it's at 12.5 on the y. So it is a reflection of part A, a reflection in the x-axis. So we can see here that state the coordinates that the point P is transformed to on the curve with the equation y equals f of 3x. So it's inside the bracket, affects the x, we divide by 3, so my new coordinates of P when it's been transformed is 1 minus 1, because I need to divide my x values by 3 and I can't touch my y values. Looking at part B, we can see that it's 5 on the outside, so we need to multiply my y values by 5 as it's a vertical stretch. So point P here, 5 times the minus 1 is minus 5, and those are my new coordinates. So first for part A, we need to sketch this graph. I'll do that quickly. So here we have the graph, y equals x plus 1, x minus 1 squared. So it's going to cross at minus 1 from this bracket, and then it's going to hit and bounce off at positive 1 from that bracket. And it's a positive x squared graph. We also know that it's going to cross the y-axis at the value 1 as well. Now, for this graph to go ahead and hit the coordinates 2, 0, that would be somewhere over here. I would need to create a horizontal stretch, and I need to multiply by 2 would take this value from here to the 2, or if I multiplied by -2, this value would end up hitting at the coordinates 2, 0. So I'm looking at those two scenarios. Remember, inside you do the opposite, so to multiply by 2 I need to divide by 2, and to multiply by -2 I need to divide by -2. So my values of A are 1/2 or -1/2. If you found the video useful, please hit a like, and if you haven't subscribed already to the channel, subscribe now.